at the same latitude and compare their climates. How about Seattle and Fargo? Now, Seattle is right near the Pacific Ocean. It's going to have a very marine climate. Fargo is about as far inland as you can get. It's going to have a very continental climate, which means it's going to have very big differences between summer and winter. What is winter like in Seattle? Well, it's very mild, it's very rainy, it rarely freezes, it's a very mild climate. What is winter like in Fargo? Well, it's cold, it's snowy, and it spends many days at temperatures far below 0 degrees Fahrenheit. On the other hand, in the summer, the temperatures in Fargo can be quite warm in the 80s, maybe even in the 90s, but in the winter they have extremely cold temperatures. So Fargo has a good example of a continental climate, whereas Seattle has a good example of a marine climate. Our third climate control will be the ocean currents. Now, we've learned about the oceanic gyres early in the semester, where these large circulation patterns in the ocean rotating in the same manner as an anticyclone. And if you look at those circulation patterns, they mean something very important for the temperatures on the west coast of continents versus the east coast of the continents. Take a look, for example, at California. California has a cold ocean current along its coast. On the other hand, take a look at, say, South Carolina. It has a warm ocean current, the Gulf Stream, on its coast. This, of course, is going to have important implications for the regional climate. California is cooler than you would otherwise expect because of the cold ocean water offshore. South Carolina is warmer than you would otherwise expect because of the warm ocean water just offshore. Another key climate control are the prevailing winds. Now, to think about the prevailing winds, you need to think back to the different sections of the course about general circulation. Most areas of the world have a prevailing wind. The wind may be different from this on any given day, but overall, the winds follow this kind of pattern. Depending on the prevailing winds, then, your air at any given location may be coming from the ocean or it may be coming from the land. If the air is coming from the land, you're going to have a more continental climate than you would otherwise expect. If your air is coming from the ocean, you're going to have a more marine climate than you would otherwise expect. Let me give you two examples. Dakar, Senegal is right on the coast. You would expect Dakar to have a very marine climate. But actually, the prevailing winds in West Africa bring dry air off of the Sahara Desert to Dakar. So Dakar has a much more continental climate than you would expect for someplace right on the shore. On the other hand, India is a fairly large landmass. You would expect it to have a very continental climate. But because the prevailing winds bring moderate, mild air off of the Indian Ocean, you actually have a very marine climate in India. Across most of North America, we have westerlies. That means that the prevailing winds are from the west. Therefore, on the west coast, the climate is more marine than you would otherwise expect. In this picture, for example, of San Francisco, you can note that the climate is really quite mild because most of the air that San Francisco experiences has just come off of the Pacific Ocean. In contrast, in Washington, D.C., where the winds are also primarily from the west, we have a very continental climate. Even though Washington, D.C. is just a matter of miles from the Atlantic Ocean, its climate is actually very, very continental. They have severe winters and hot summers. Our fifth important climate control are the global wind and pressure systems, which is another way of saying the general circulation, but this time we're talking about the pressure patterns. If you're in a part of the general circulation where there's large-scale subsidence and high pressure, it doesn't really matter whether you are near the coast or you're near the center of the continent, you're going to have a dry climate. If you're under the ITCZ, it doesn't matter whether you're inland, it doesn't matter whether you're on the coast, it doesn't matter if you're an island over the ocean, you're going to have a wet climate. The Amazon River is in many ways our best example of this. The Amazon River is in the center of South America, a rather large continent. You would expect it to have a very continental climate. On the other hand, the Amazon Basin is under the ITCZ. It's not a very continental climate with dry weather. It has, in fact, a very, very moist climate because it's under the ITCZ. The presence of mountain barriers make a sixth control on the climate. This refers back all the way back to the first unit of the course where we learned about what happens when air goes over a mountain range. As illustrated in this picture, you can see how as air goes over the mountain range, it cools, there's condensation, and you get a moist climate on the upwind side of the mountain, or the windward side of the mountain range. Whereas on the downwind or lee side of the mountain, you have adiabatic heating, you have dry conditions. This is the rain shadow. So the presence of a mountain range can greatly change the climate of two locations that are very close to each other. Let's consider the climate of Washington State. Now, in Washington, there is a very large mountain range that separates eastern Washington from western Washington. If we pick two cities in Washington, perhaps Seattle, which is on the windward side of the mountains, and Yakima, which is on the lee side of the mountains, and compare their climates, we'll see the importance of the mountain ranges in determining their climate. Well, we've already seen and talked about the climate of Seattle before. It's very marine. It rains a lot, it's very mild, it rarely freezes in Seattle. In the summer it rarely gets all that hot. Seattle has a very marine climate. In contrast, just a few hundred miles away, in Yakima, on the lee side of the mountains, it's extremely dry, and the climate is much more continental. The winters are quite cold, the summers are quite hot. So the presence of the mountain range has really made a big difference as to what kind of climate you can receive. On the windward side, you're more likely to have a marine climate. On the lee side, you're more likely to have a continental climate. Our seventh and final climate control is going to be altitude. And I think that this picture of Mount Fuji in Japan really illustrates the importance of altitude with respect to climate. Generally speaking, higher places are going to be colder. In this case, you can see how, despite the fact that we obviously have a very mild climate at low elevations, once you get up above the tree line and up near the top of Mount Fuji, it's obviously quite cold and can support a more or less permanent ice pack at the top of the mountains. Another good example would be Tibet. Tibet is up in the subtropics. It's at approximately the same latitude as, say, the Sahara Desert. Yet Tibet is completely covered with snow. That's where the Himalaya mountains are. The altitude is quite high. Typical altitudes on the Tibetan Plateau are something like 20,000 feet or something like that. Quite cold, and as a consequence, the elevation is determining the climate of these regions. Now that we know all of these different ways to classify the climate, the different controls of the climate, we can start wondering how we're going to classify different climates. If you're thinking that with all these different climate controls, it's going to be hard to say that any two regions have exactly the same climate, you're right. However, there is enough similarity of climates in a given region that allow us to divide the world up into a variety of different climate zones. The most famous way to do this is what's called the Köppen system. This was developed by a guy named Vladimir Köppen in the early 20th century. And Köppen came up with a really good realization. Köppen realized that there would never be enough observing stations in the world to classify every point's climate. No matter how many observations you have, let's say you have an observation in Omaha and you have an observation in Valley. Well, you could always ask, well, what's the climate like between Omaha and Valley? So you'd need another station. And then you could ask about what the climate was like between those two stations. There would never be enough. Köppen said we don't need all these observations because nature has provided us with a way to make observations. Plants. Plants are a natural measure of the climate of a region. Regardless of whether or not there's an observing station nearby, the local plants do a fine job of recording and observing the climate because they depend on the climate in order to survive. Take, for example, palm trees. Palm trees are a natural recorder of the climate. They only live in places where palm trees can live because it's warm enough for them. These palm trees, which are out here in the snow, are not going to make it. Let's think about cactuses or cacti. Cacti live in parts of the world that are dry. Their root system requires dry soil. Cacti don't live in places where it's too moist. In this case, this cactus is going to die because it's not in the correct climate anymore. There must have been some kind of climate change that increased the chances of there being flooding or whatever happened here. So all plants live where they can live. If there's a reason why the plant can't live there, it doesn't live there. And as a consequence, the plants of a given region make a really good way of establishing the climate boundary. These lichens only live in certain places where the temperatures are a certain range of moisture occurs. If the wrong kind of climate is there, that lichen won't live there. These bougainvillea